Disclaimer: the information in this episode is for educational purposes only and is not medical advice. Peptides like Coristatin are still being researched and should not be used without professional guidance. Always consult a qualified healthcare provider before starting or changing any treatment. Today we are diving into the world of Coristatin peptides. Coristatin is a relatively lesser-known peptide, but one that has sparked scientific interest due to its relationship with angiogenesis, inflammation, and tissue remodeling. The story of Coristatin begins with its origins as a peptide fragment connected to the protein coristatin, which itself has functions tied to the nervous system, immune signaling, and vascular regulation. Researchers became curious about whether fragments like Coristatin could carry specialized bioactive roles, and this has led to some intriguing findings. When we talk about Coristatin, the first area to understand is angiogenesis, which is the formation of new blood vessels. Angiogenesis is critical for healing, tissue repair, and growth, but it is also implicated in disease states such as cancer, where tumors hijack this process to feed themselves. Coristatin has been observed in experimental studies to interfere with abnormal angiogenesis, making it an interesting candidate for research in conditions where controlling blood vessel formation could be beneficial. This includes not only oncology but also disorders involving abnormal vascular growth or inflammation. Beyond angiogenesis, Coristatin has drawn attention for potential anti-inflammatory effects. Chronic inflammation is linked to a wide spectrum of health problems, from autoimmune disorders to metabolic dysfunction. Early evidence suggests that Coristatin may modulate immune signaling in ways that calm excessive inflammation. This does not mean it acts as a blanket suppressant of the immune system, but rather as a balancer, nudging the system toward regulation instead of overactivation. Let's explore how Coristatin might be applied in real-world settings. In preclinical models, Coristatin has been studied for its ability to suppress pathological angiogenesis in diseases like arthritis, where joint inflammation is often sustained by new blood vessel formation. By reducing abnormal vascular growth, it may cut off the supply lines that perpetuate inflammation. Similarly, in experimental cancer models, peptides like Coristatin have shown the capacity to slow tumor vascularization, which is one of the mechanisms tumors rely on to expand. Another interesting area of research is the nervous system. Because Coristatin is linked to cortistatin, which itself is a neuropeptide related to sleep regulation and neuronal excitability, scientists have considered whether Coristatin could have neurological implications. While this area is far less studied, there are hints that peptides in this family may have crosstalk with the brain and immune system, two areas that are tightly linked. If future research bears this out, it could open doors to studying Coristatin in neurological disorders where inflammation plays a role, such as multiple sclerosis or neurodegenerative conditions. Of course, it is important to highlight what we do not yet know. Much of the research on Coristatin is preclinical, meaning it has been studied in lab models but not extensively tested in humans. This means that while the peptide shows promise, its safety profile, optimal dosing, and long-term effects remain unclear. Unlike more established peptides such as BPC-157 or thymosins, Coristatin is still very much in the exploratory phase. This leads us to the question of access. Coristatin is not something you will typically find offered through common peptide vendors, at least not in a standardized or well-documented form. Because it is more of a research tool than a therapeutic at this point, availability is limited to labs and experimental contexts. For those interested in peptide science, Coristatin serves as an example of how rapidly the field is expanding and how many specialized bioactive fragments are being discovered and characterized. So, why should you care about Coristatin? The answer lies in the bigger picture of peptide therapeutics. Every peptide that enters the research spotlight gives us another piece of the puzzle about how our bodies regulate healing, immunity, and cellular signaling. Even if Coristatin itself never becomes a widely used therapy, the insights gained from studying it could inform the development of next-generation drugs. For example, synthetic analogs of Coristatin might one day be engineered to selectively block pathological angiogenesis without interfering with healthy repair processes. Let's imagine some possible future applications. In cancer therapy, Coristatin derivatives could be used in combination with chemotherapy or immunotherapy to weaken the tumor's blood supply, making it more vulnerable to treatment. In chronic inflammatory diseases like rheumatoid arthritis, they could help reduce joint damage by shutting down the vascular component of inflammation. In eye diseases such as macular degeneration, where abnormal vessel growth damages vision, Coristatin-inspired therapies might help preserve sight. These ideas are speculative but grounded in the biological mechanisms being uncovered. As we move through this conversation, it is important to appreciate how peptides like Coristatin illustrate the overlap between biology, medicine, and innovation. We are living in a time when peptide-based therapies are expanding from niche experimental use into mainstream medicine. Insulin was the original peptide therapy, and now we have GLP-1 receptor agonists revolutionizing metabolic care, thymosin derivatives in immune modulation, and collagen-related peptides in regenerative medicine. Coristatin may never reach that level, but it contributes to the ongoing story. Let's step back and reflect for a moment. What does the existence of Coristatin tell us? It shows that nature encodes countless microregulators in the form of small peptides, many of which we are only beginning to identify. It also shows that research often uncovers unexpected intersections, such as the link between vascular growth, inflammation, and neurological signaling. And it reminds us that while some peptides leap quickly into clinical relevance, others remain in the wings, quietly shaping our understanding until the right breakthrough brings them forward. Disclaimer: this discussion has been for educational purposes only. Coristatin is not approved for human use, and any applications mentioned are hypothetical and based on early research. Please consult with qualified medical professionals before considering any peptide-related intervention. Thanks for listening, keep learning, and stay curious.